In this lesson, we're going to introduce geometry proofs in the way that MUS does this. So what are proofs? In lesson 22, we went over different theorems and axioms and postulates that we have looked at before in geometry. So remember that those notes are from your lesson 22 notes. Just a long list of theorems and postulates that we've used. And there probably are a few that we may be using in some proofs in the future that aren't listed here. But I think this is a good list to get you started that you'll be looking at every time you're trying to do a proof. So proofs are a big part of geometry, but they're also any part of any subject in math and even beyond, because you have to be able to prove what you know to be true. Anytime you're trying to convince somebody what you're saying is true, you have to back it up with some reasons. And so that's all a geometry proof is. Let's look at this first example together. We have a picture, usually with our geometry proofs, and then we have some givens. And that means they're telling us something that we already know. And then it tells us what we're trying to prove. So on our givens, we have that NMP. So NMP is this angle right here. And I like to mark them when I start reading these so that I can see them on my drawing. NMP is congruent to MPN. So I'm going to mark them like this. I have marked them with the same marking of one arch. So I know that those are the two that I'm talking about are congruent. And then we have QPR. So QPR, that's this one. And I'm going to use a different marking on that because it's a different set. QPR is congruent to PRQ. So I'm going to mark that one. Now I marked these two because they're congruent. I marked them with like 2 arcs, and then these two were congruent. I marked them with 1 arc each. We're supposed to prove that MN, this line over here, is parallel to QR. So I wonder how we're going to have to prove that. Let's just start. A lot of these examples and getting you started, we're going to give you either the statements or the reasons so you know what the steps are, and you're just trying to figure out either what the reason is or when they give a reason what the statement is. So NMP is congruent to MPN. And that's one of our givens. So all we write is given. It was given to us. The next one is MPN is congruent to QPR. So let me draw that with a different color. What is MPN? That's this one right here. That's congruent to QPR. That's this one right here. How are those congruent? Hopefully you see them as vertical angles, and we can go back up to our theorems and postulates. And it was number 8, that vertical angles are congruent. So that's where all that we did back in the first semester comes back to us. We have to be able to relate the angles and think about, how are those two angles related? What do we call it? Are they congruent? Are they supplementary? So all of that should be coming back to you as we do these. So these are vertical angles, and that number 8 told us that vertical angles are congruent. So when we write in here, sometimes we can abbreviate a little bit, but I'm going to go ahead and write out that vertical angles are congruent. And what I'm doing in my reason here is I'm saying, I know that those are vertical angles, and my postulate said that vertical angles are congruent. So that's what I'm writing, and that's how I can prove that these two are congruent. So then I'm looking at my next one. NMP is congruent to QPR. So that's not one of our givens, that's NMP. So that's this one down here is congruent to QPR. That's the one we just did up here. So why can we say these are congruent? So I'll go ahead and draw it with the 2 arcs that these two had. And so how are those congruent? Well, let's think about the very first one we had said that these two were congruent, and then we just did vertical angles that these two are congruent. So that's that whole, if A equals B and B equals C, if these are all equal, then I can kind of replace those B's and say that A must be equal to C. So that's called the transitive property. It's up here on one of our ends. So if A is equal to B and B is equal to C, then we must know that A is also equal to C. So that's the transitive property of congruence. Now the proof is going to work on a few things. When you do proofs all on your own, if you're coming up with the statement orders, sometimes the order doesn't matter. You do need to put things first that you're using later. But if I had listed all of my givens at the very beginning, which is what a lot of people like to do, like I'm just going to list everything I'm given, even if I'm not using it right away. So I can put given as the reason and it just covers everything. That's fine. In this proof, we didn't go in that order, but you very easily could have put this given up at the top as well. So this is QPR is congruent to PRQ. So that's one that we already drew with those two angles, except now we have a bunch of angles with two arcs in them. So anyway, that one was given. Now we look at PRQ. So that's this one that we haven't really talked about yet. We just know that it's congruent to this one. And now they're saying it's also congruent to NMP, this one down here. So if we look at the last two steps that we've done, NMP was congruent to QPR and QPR was congruent to PRQ. And now we have that NMP is congruent to the PRQ. So we took out this middle step. So that's that A equals B, B equals C. So then A also equals C. So we're down to the A equals C. So again, that is the transitive property of congruence. And then our last one says that the lines are parallel. So let me maybe highlight what that really looks like. So these lines are parallel. So if I draw a little past on the lines, maybe it will help me see that this right here is my transversal. And these two angles that I just said were congruent are alternate interior angles of these yellow lines and this transversal. So if we remember back when we talked about alternate interior, alternate exterior, corresponding angles, they're all congruent if we have two parallel lines cut by transversal. And then we talked about converses. That means that we can kind of read it backwards. If those two angles are congruent, then the lines cut by that transversal must be parallel. And so that's what we're using here. These are alternate interior angles. So interior meaning they're inside of the parallel ones, and alternate meaning they're alternate on either side of the transversal. So they are congruent. That's what we have proved in that step above. So we could say if alternate interior, and you can see I'm using some abbreviations, if alternate interior angles are congruent, then the lines cut by the transversal must be parallel. And so that's how we proved that lines MN and QR are parallel. Now we're going to look at one from our proofs worksheet that I sent home. So proofs A worksheet just has two for you to try to give the reasons for. So looking at this one, we just have two angles in here. We are given that 1 and 2 are complementary. So 1 and 2 are complementary, that was given. Now the next one says that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Well, how come we can say that the measure of angle 1 and the measure of angle 2 equals 90 degrees? Well, that's what complementary means. In other words, that's the definition of complementary. So sometimes we just have to state the obvious. We said they were complementary, but what does that mean? It means that they add up to 90 degrees. And then it says that the measure of AXC is equal to the measures of 1 plus the measure of 2. You're probably thinking, of course, I mean, they're inside of there. They are. Well, so what are we saying? The addition property of angles, or two angles that are next to each other make up the whole angle. So I'm going to use the addition property of angles. The two angles are next to each other, they add up together, and they're going to equal the whole angle. And then it says the measure of angle AXC that we just named, that we said was the measure of angle 1 and 2, is equal to 90 degrees. So I know that we were using the transitive property in the last one, but when we put numbers in there, sometimes we just call it the substitution property. So I would take either answer on this, whether you put transitive because we're taking this and this, A equals B and C equals A. So then we could replace the A with the B and C. So you could call it transitive, or you could say substitution. We're substituting this 90 degrees in for where M1, the measure of angle 1 and the measure of angle 2 were. Usually when it refers to numbers, you more use the substitution. When it refers to congruence, you use the transitive property. But in my opinion, they're kind of one and the same. So, some teachers may be more picky because it really is, transitive is more with congruence and substitution is more with numbers. If you had that, X is equal to 17 plus 6, and you had 17 plus 6 is equal to 23, then you could say X is equal to 23. You're substituting in that. But again, you could also say it was a transitive property. So then we have that AXC is a right angle. And again, you're saying, of course, we've been saying it equals 90 degrees and a right angle equals 90 degrees. Yes, but we're specifically saying it was 90. Now we were giving it a number, and now we're giving it a name. And we're giving it a name because that's the definition of a right angle. So again, a lot of times it's really just a definition thing. You're defining it because you said it was this. So it's the definition of a right angle. And then because this is a right angle and 90 degrees, then XA must be perpendicular to XC. And that would be the definition of perpendicular. Perpendicular means that they form right angles. So if we have a right angle, then those two lines must be perpendicular. So again, we use a lot of definition reasonings on this one, but that's what we do sometimes. Sometimes you're going to use a lot of substitution and transitive and relating them, and sometimes you might just be using a lot of definitions. So the definition of perpendicular, because the definition of perpendicular is that the lines form right angles. Okay, so hopefully this helps, and then you just have one left to try on proofs worksheet A.